All right, friends, this is going to be your probability test review. We are working on this in class and maybe some time at home, but you are going to attempt to complete all the problems first, and then you will come here to check your answer choices. As always, if Mrs. Brown makes a mistake and you are the first one to find it, she will reward you with a no homework pass or a future assignment. But here we go. So number 1, Joy can choose to ride the bus, walk, or carpool to school on Thursday and Friday. Create a tree diagram to display the sample space. So I am going to choose to start with bus. Then she could walk or carpool. And we could bus on Thursday or we could bus on Friday. We could walk on Thursday, or we could walk on Friday. And we could carpool on Thursday or carpool on Friday. On your actual test, there are a couple of tree diagrams like this where you have to drag and drop the kind of branches into place. So hopefully that made sense to you, because there are going to be a couple questions like that on your test. Number 2, at a pizza shop, you can choose thick or thin crust, red or white sauce, and toppings of pepperoni, cheese, or vegetarian. Create a tree diagram to display the sample space. All right, I'm going to start out with crusts. So we have thick and we have thin. Okay, from those two choices, you can do red sauce or white sauce on a thick pizza. You can do red sauce or white sauce on a thin pizza. From there, on the thick red, we could do pepperoni, we could do cheese, we could do vegetarian. We could do a thick crust with white sauce with pepperoni, cheese, vegetarian. And then over here with thin red, we could do pepperoni, we could do cheese, we could do vegetarian. And then thin white, pepperoni, cheese, vegetarian. So that comes out with 12 different possible answer choices for that tree diagram. Again, you are going to do a couple sample space questions with drag and drops. Okay. For number 3, a basket of beads contains 8 red, 6 yellow, 6 green. I've told you before, I like to write that on the side so that I can have a total there for a second. A bead will be drawn from the basket and replaced 60 times. What is a reasonable prediction? So we are going to be setting up a proportion in order for a green bead to be drawn. So the probability of a green, okay, I'm going to find a total here before I do anything else. 8 plus 6 is 14, plus 6 more is 20, so there are 20 total. All right, so we would like the probability of green. So 6 out of 20, so 6 greens out of the total are going to be green. If we draw 60 times, okay, I could simplify here if I wanted to, but I don't necessarily need to, because I can see right here that 20 times 3 is 60. So 6 times 3 is 18. So if we were to draw 60 times, our probability of selecting a green would be 18. Okay, that's just like the predictions maze that we just got finished doing in class. All right, let's look at number 4. The list shows the different pizzas sold by noon at a local pizza shop. We have 11 pepperoni, 7 supreme, 6 cheese, and 3 Hawaiian. Based on these results, if 189 pizzas were sold by the end of the day, how many would expect it to be cheese? So my probability statement needs to be the probability of cheese. They're so sweet and already did the list for me, but I need to come up with a total. So 11 plus 7 is 18, plus 6 is 24, plus 3 more is 27. So there are 27 total. So the probability of cheese is 6 out of 27. And again, we are making a prediction with the expected. So 27 times 189. Okay, so I could do a couple of things here. I could simplify if I wanted. Hang on, the bell is about to ring. Hang on. All right, so we're going to set up the proportion 6 of cheese out of 27 total. I could simplify here if I wanted to. They're both divisible by 3, but I know that 27 times 7 is 189, and 6 times 7 is going to be 42. So the probability that there will be 42 cheese pizzas out of 189 sold. Okay, so we have number 5. Amos is randomly selected, or I'm sorry, Amos is going to randomly select a donut from a box containing the donut shown in the table. 2 statements are made. Which statement or statements are true? 1, Amos is 3 times as likely to select a filled donut as a glazed. 2, Amos is equally likely to select a filled or a sprinkled donut as a glazed. Okay, so first we have glazed with 6, filled with 2, sprinkled with 4. If we add those all together to get a total, we are going to have a total of 12. So the first thing we're going to do is the probability of a filled donut, which is 2 out of 12. And then the probability of a glazed, which is 6 out of 12. So is Amos, I'm sorry, I was trying to read that again. Is Amos 3 times as likely to select a filled donut, so 2, as a glazed donut, 6. So this is going to be a no. Okay. For 2, Amos is equally likely to select a filled, so we know that's 2 out of 12, or a sprinkled, so that's 4 out of 12. Okay. We're going to combine those two together because of that word or, filled or sprinkled, as a glazed. So 6 out of 12 and 6 out of 12. So we would have just 2 only for C, for number 5. Okay, let's look at number 6. The spinner below is spun once. What is the probability of not landing on a heart? So not, we're looking for the complement, so no hearts. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 out of 7. Or you could have a little apostrophe with the heart, would equal 5 out of 7. Don't forget the probability statement. Ours is right there. All right, number 7. There are 5 marbles in a bag. 3 are green, 2 are yellow. There are 5 total. You draw a marble, replace it, and then draw another. What is the probability of choosing 2 yellow marbles? So we have the probability of yellow and the probability of yellow. We are replacing it, okay? So yellow would be 2 out of 5, and then this yellow would be 2 out of 5. So the probability of changing 2 in a row, so this is a compound probability. We're going to go ahead and multiply. 2 times 2 is 4. 5 times 5 is 25. So the probability of 2 yellows is 4 out of 25. And our probability statements are right there. Okay, number 8. 4 coins are flipped. What is the probability of all coins landing on heads? So we have the probability of heads. We are flipping 4 coins. So 1 out of 2 times 1 out of 2 times 1 out of 2 times 1 out of 2, because there's 1 opportunity for heads out of 2 sides. So 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So this would be, the probability of heads would be 1/16, and our probability statement is right there. Okay, number 9. Each week in the library, Miss Hoskins, or Haskins, I can't tell if that's an O or an A, features popular books in the display. This week includes 3 mystery, 4 biographies, 6 sci-fi books, and 2 dystopian fantasy books. If we were to add those together, because we are going to need a total, we would have 15. Jack randomly selects 1 book to read. What is the theoretical probability that this book is a biography. So remember, theoretical means that we are presented with our information and we have not done any kind of experiment. This is just what would likely happen based on the information that we are given. So that's theoretical probability. So we have the probability of a biography. Okay, so we have 4 out of 15. I can't simplify that further because they don't have a number that they are both divisible by. So it's 4 out of 15. Number 10. Do some finagling with my paper here, okay? A bag of marbles includes only green and red. The results of the experiment are shown below. So this is an experimental probability. Let me zoom in because this is very small. All right, there we go. That's a little bit better. Okay, so this is an experimental probability because this has actually happened. So what is the experimental probability of selecting green? Well, there's 10 trials and we have 1, 2, 3, 4, 5, 6, 7 green. So the probability of green is equal to 7 out of 10. What is the experimental probability of selecting a green or a red marble? So the probability of green or red would be 10 out of 10 because that's the only options that we have. And both of our probability statements are right there. Okay. Number 11. Let me move a little bit. I have about 4 minutes before this first video cuts me off. So I'm trying to keep that in mind. Destiny places the word October into a bag. What is the probability that she selects a B and then an O without replacement? So we have the probability of a B and the probability of an O. Okay, so the probability of a B, there is 1 B, and the word October has 1, 2, 3, 4, 5, 6, 7 possible letters in it. And then remember, we are not replacing it, so we only have 6 tries this time, 6 letters, and 2 of them are O's. We can simplify that to being 1/3, and that would be 1 out of 21 chances to get B, not replacing it, and then getting an O, 1 out of 21. And both of our probability statements are right there. All right, I'm going to go ahead and pause right here, let this upload, and then start another video for the rest.